Okay, geometry, this is lesson 9.5, dilations. The objectives, students be able to understand dilations, images of figures. Now, make sure you get that objective written down at the top of your page. You can stop the video to do so. Now, essential understanding. You can use a scale factor to make a larger or smaller copy of a figure that is also similar to the original figure. Now, that's just multiplying by the scale factor, and you can use it as a multiplier. If the scale factor is larger than 1, it'll make your value grow. If the scale factor is less than 1, it'll shrink your value. And we'll talk more specifically about that as we go through the problems. A dilation with center C and scale factor n, where n is greater than 0, is a transformation with these two properties. The image of C is itself. That is, C prime is equal to C. And for any other point, R prime is on ray CR, and CR prime is equal to n times CR, or n is equal to CR prime over CR. So let's talk about this thing. Here's the deal. This image of a dilation is similar to its pre-image. Okay, so I've got this image right here. Let's lock that down. Okay, so I'm looking at this. This original distance, if I can get this highlighted. So I've got CR, okay, is my original distance. And then I have this distance CR prime. Now, that is a growth. Now, notice how big this is and how it centers from this point. So this is my center of enlargement, C, and that because that's the center, C and C prime are the same. I could also look at it as I'm going to take PR and grow it to P prime R prime. And if I take P prime R prime divided by the length of PR, I will get N. Or if I take C prime R prime and CR and divide CR prime, that's this longer one. Maybe let's change that color. So if I do it this way, if I take this and change the color to red, if I take this value and put it on top, so that's on top, and divide, excuse me, I lied. I hate it when I lie. Let's do that over. If I take this value and put it on the bottom, that's red, good. So I'm looking at red. I should be looking at red. Put that value on the bottom. We'll wait. Okay, put that value on the bottom. Okay, so that's be on the red because that's my CR, my original. And then take my blue and put it on top. Okay, so I take my blue and put it on top. And that's my image. So pre-image on the bottom, image on top. I can find my scale factor, n. Okay, or I can find the original, the enlargement, okay, my CR prime, by taking my original length and multiplying by scale factor. So those are the two ways I can do this problem. And that's how it will work. So you can show that the scale factor of a dilation has the same value as the scale factor of a similar figures, pre-image and image, with the image length in the numerator. Okay, so I've got the image length in the numerator and the pre-image length in the denominator. So if corresponding points have the same scale factor, then I can say that they are similar. So a dilation is an enlargement if the scale factor is greater than 1. The dilation is a reduction if the scale factor is between 0 and 1. Now, this states that it's an enlargement, but I'm going to use the ideas of n to show you that. I have A, the black is my original, so it's my pre-image. Black is pre-image. A prime, my A prime is A, it's my image. Okay, so let's look at that as my black is my pre-image. So my pre-image is 2. my image is 4. So I am going to put, and it's important for me to know the difference. Pre-image, okay, my image is 4, my pre-image is 2. Okay, so I plop that in, I have 4 over 2, and I find that my enlargement, my scale factor is n. Well, the scale factor is 2. It's 2 times larger, so this is, each side is 2 times larger. The shape itself is 4 times larger for area. Okay, I want you to do the same thing. I have a pre-image. Okay, I have my image. So I take my pre-image and image. Again, I have my image, put it on top, excuse me, my pre-image, yeah, my image on top, and I got to get my pre-image, and I'll do my pre-image with a different color on this one. My pre-image is on the bottom. Okay, I pop them in. I get 2/8, which is the same as 1/4. And they say here, hey, scale factor is a 1/4. Not only am and I'm finding how it went from the original shape to its image. The original shape is pre-image. Now, finding a scale factor. I've got to go to the original shape. Remember, the same stuff I'm going on, okay? So I'm still going to be working with my scale factor is n is equal to x prime t prime, yeah, x prime t prime, and xt. Be careful. I always have people mess this up. X prime t prime is 4 plus 8. That's 12. xt from the original, remember, this is image over pre-image. Image is on top. Okay, maybe we should write that in there. And pre-image. And I'm doing this at my computer, so this makes it difficult to get things going, but I got image over pre-image. Okay, and that's what I'm dividing. So my image is length 12. My pre-image is length 4. Okay, now remember, that's where we got them. You've got to make sure you know the difference. And people go, oh, Bloom, I can't believe you're doing it this way. I totally get it. I say, I totally know that you're going to get it wrong if you're one of those people that aren't writing down the difference here. So make sure you know that this is the pre-image. And the image is the two sides added together here because this is x prime, t prime, this whole length, which is, and that should have been blue. Let's go, and that should have been 12, that whole length. I'm making that blue so you see it. Okay, and that the pre-image is just 4. Now, this is 3 as an answer instead of 2. Do not screw this up. Pay attention. My scale factor is 3 here. Okay, this is an enlargement. It got bigger. So my scale factor should be bigger than 1. Now, J prime, K prime, L prime, M prime is the dilation image of J, K, L, and M. The center of dilation's O. Is the dilation an enlargement or a reduction? Okay, I'm going from J to J prime, so it's going in. So it looks like it's going to be reduced. So I'm pretty confident it's going to be, I'm looking for scale factor, I'm pretty sure it's going to be a reduction, but remember, I'm going to go from K prime, L prime, K prime, L prime, KL. I could have picked any of these, but K prime, L prime is 2 units. KL is 4 units. Do you see that? That was really easy to do. So I can put that in there, and I can put 2 over 4 because this is 2 over 4. Okay, totally is going to work, and it's going to be half. So this is a reduction. Okay, when I look this one over, this is a reduction. It got smaller. All right, is the dilation enlargement or reduction? It's a reduction. What's the scale factor? 1/2. Okay, so I've got those 2 things done. So that's my scale factor is 1/2, which is n. Let's make sure I got everything done there. Yeah, I did. Good for me. Now, when I talked to you about it earlier and talked about changes, we can totally get these changes done on a grid Okay, and we can use a multiplier to help us out. Okay, now according to what they've got here, my original px and my final p prime nx and y, the difference, they multiplied the pre-image times the scale factor to get your final image. Well, if I'm going to multiply my pre-image times image, I'm going to go 2 times, hey, my scale factor is 2. 2 times 2 is 4. 2 times 0 is 0. 2 times -3 is -6. 2 times 1 is 2. 2 times 0 is 0. -2 times 2 is -4. Holy cow. That's all I have to do, and that'll be it. That'll take and enlarge my figure according to the center of enlargement, which is 0, 0. So I'll go out here for 1, 2, 3, 4, 0. Back here at 6, 1, 2, 3, 4, 5, 6, up 2, and 0, 4. 1, 2, 3, 4. Now, this is my image enlarged based on that. This red triangle, each side is 2 times larger than the sides of the blue. Your turn, give it a try. Okay, turning me back on, I'm multiplying this by half, so half of 2 is 1. Half of 0 is still 0. Half of -3 is -3 halves are 1.5, -1.5, and half of 1 is 0.5. And 0 is -2, so 0 times 1/2 is 0, and -2 times 1/2 is -1. That's crazy. All I have to do is multiply the scale, each point by the scale factor, and that's the change, and that's all I have to do. But again, this is a vocabulary idea, because if you don't pay attention, you will not notice that. So it's -1/2, 1/2, so it's right there, and that's 0, 1. So this is my new triangle with my P prime, my G prime, and my Z prime. Okay, now let's practice this. The dilation has center 0, 0. Find the image of each point for the given scale factor. Well, I've got a point, I got a scale factor. You ready for how hard this is? What's 2 times 1? It's 2. 2 times -5, -10. That's it. And it's an enlargement because it got bigger, because my scale factor is bigger than 1. Here, go ahead and multiply. Hopefully you got 0 and 2, and because this scale factor is smaller than 1, it's a reduction. And the last one's really tough. 0 times 10 and 0 times 10. That's just going to be 0, and it's an enlargement because it's 10 times larger. That's my growth. Now we got 2 problems left. Okay, dilations and scale factors help you understand real-world enlargements and reductions, such as images seen through a microscope or on a computer screen. Using a scale factor to find a length. Biology, a magnifying glass shows you an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows an apple seed under this magnifying glass. What is the actual length of the apple seed? So I got pre-image and image. Okay, so they're talking about the N is my 7. Okay, and P is what what's the actual length of the apple seed. In this picture here, this is 1 3/4 of an inch. Okay, that's my image inside my microscope. That's my image. This is my enlargement. I'm going to find P. How would I get P by itself? Divide by 7. So I can divide by 7 and find it's 0.25 inches. Word problem, word answer, actual length is 0.25 inches. Okay, next problem. Ooh, next problem is below. I'm sorry. I should say our last problem. Same idea with this. We're going to do the same. N pre-image is image. So I've got my N pre-image image. The height of a document in your computer screen is 20.4 centimeters. When you change the zoom setting on your screen from 100 to 0.2 or 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. So I got a scale factor already. I know N. What's the height of the new image? And I already know my original P's. Okay, so 0.25 and my pre-image is 20.4. So what's my image height? So I just multiply these two together. It's all about setup and knowing N is my scale factor. I take my pre-image value times N and I get my image value. Okay, I'm just going to multiply them together and find my image value. So I've got 5.1 as my image value. Okay, so what's the height of the new image? The height Oh, actually, it's right here. Height of the new image. I thought I'd written that in. The new image height is 5.1 centimeters. Okay, summary. Objectives. Students will be able to understand dilation image of figures. Write a couple sentences about something that you learned today about the learning objective, which is students will be able to understand dilation images of figures, then rate yourself from 0 to 4. Thanks for your time.